Welcome to today's video on quadratic functions. First of all, a quadratic function in standard form is any function where it's x minus, it's a times x minus h squared plus k. That is the standard form. And remember, any quadratic function is in the shape of a parabola. Now, sometimes if it's not in standard form, you'll see it as f of x equals ax squared plus bx plus c. So those are the two forms that you will see it in. If a is positive, the parabola opens upward. And if a is negative, the parabola opens downward. So it's either going to be like that, positive, or that, negative. The vertex is the point at which the parabola changes direction, especially from increasing to decreasing or vice versa. From increasing to decreasing. Or vice versa. The axis of symmetry is the line which acts as a mirror. The parabola is the same on both sides. Now, for the vertex, it's just HK. The axis of symmetry is the line x equals h for the vertex. So in standard form, as I showed you, f of x equals a times x minus h squared plus k. The first thing we're always going to do is determine whether the parabola opens upward or downward. Then you determine the vertex of the parabola. Then you find the x-intercepts by solving, setting it equal to 0. And then the y-intercepts by computing f of 0. And then we're going to plot all that. So for example, f of x equals negative x minus 1 squared plus 4. So the first thing I know is it opens downward. Step 2, the vertex is equal to 1, 4. Step 3, the axis of symmetry is equal to x equals 1. Also in step 3, the x-intercepts, so basically I set it equal to 0 and I solve. And then when I subtract 4 here, Sorry, rewind that. I subtracted 4, so then I divide by the negative 1. So I get 4 equals x minus 1 squared. You square root it. Remember, that's going to be plus or minus. 2 is equal to x minus 1. So you have 1 plus or minus 2 equals x. So that means the x-intercepts are 3, 0, and negative 1, 0. Those are my x-intercepts. So now, step 4 says find the y-intercept. So, I put 0 in for x. So I get the opposite of negative 1 squared plus 4. So the opposite of 1 plus 4 is 3. So the y-intercept is 0, 3. So now I'm going to plot all this. So the vertex is 1, 4. The y-intercept, or sorry, the axis of symmetry, I'll put it in red. Axis of symmetry is x equals 1. Then I have the y-intercept of 0, 3. And I have the x-intercepts of 3, 0. And negative 1, 0. And notice, it's symmetrical on the line of the axis of symmetry. Notice the x-intercept is 2 spaces away from the axis of symmetry and 2 spaces away to the right. So that means using symmetry, since this is 1 space over, then this is also going to be 1 space over. So I'm going to have 2, 3 as my point here. And now it's a symmetrical parabola, and I'll just graph it. There you go. All right, let's try the next one. This one opens upward. The vertex is 2, 1. The axis of symmetry is x equals 2. The intercepts well, right here I get negative 1 equals x minus 2 squared. Notice it's a squared and a negative, so that means that there's no solution here in the real number system, which means there's no x-intercept. And that makes sense. If the vertex is 2, 1 and it goes up, it's never going to touch the x-axis. Y-intercept is 5. So then we'll graph what we have here. So the intercept is 2, 1, or sorry, the vertex is 2, 1. There's the vertex. The y-intercept is 5. And then the axis of symmetry is x equals 2, which means that if this is 2 spaces to the left, then you need a point 2 spaces to the right here, which is 4, 5, and then you can make your parabola using the symmetry. All right, if you have a quadratic equation in the form ax squared plus bx plus c, then you can find the vertex because x is equal to negative b over 2a. And then to find the y-coordinate, you just put that x-coordinate into the function to find the y. So for example, here, to find the vertex, well, first of all, since the a term is negative, it opens downward. The vertex, so x equals negative b over 2a, which means it's, in this case, negative 4 over 2 times negative 1, which will give you positive 2. And then f of 2 is equal to negative of 2 squared plus 4 times 2 plus 1. So it's negative 4, because 2 squared is 4, plus 8 plus 1. So it gives you 5. So the vertex is 2, 5. The axis of symmetry is x equals 2. Then the x-intercepts, well, x-intercepts, so we make 0 equal, sorry, let me get the equation here, negative x squared plus 4x plus 1. So here's the deal, it's not factorable, so then we can do the quadratic formula, a equals 1, b equals 4, c equals 1, so we go negative b plus or minus the square root of b squared minus 4ac all over 2a, which is negative 2. So we have negative 4 plus or minus the square root of 12 over negative 2. So then we have negative 2 plus or minus 2 rad 3 over negative 2, which means that if we divide these by 2, we have negative 1 plus or minus, actually, sorry, because we have negative over negative, so we have 1 plus or minus rad 3. Those are our x and y intercept. Sorry, that's our x-intercept. We have 1 plus rad 3, 0, and 1 minus rad 3, 0. And then our y-intercept, when we put 0 in for x, we get 1. So then we graph this. So here's our thing at 2, 5. And then our y-intercept of 0, 1 is right here. We have our axis of symmetry. Of x equals 2. So then when we graph 1 minus rad 3, well, rad 3 is going to be bigger than 1, so it's going to be negative something right here. So there's 1 minus rad 3 comma 0. And then 1, if we draw the symmetrical point to 0, 1, we get 4, 1. And then we can put 1 plus rad 3 comma 0 there. So then there's our parabola. Now, when it asks for domain and range, our domain is all real numbers, and our range is less than or equal to 5. Now notice, if the A term is positive, then the vertex will be at the bottom, which is called a minimum value. And if the A term is negative and it goes down, then the vertex is a maximum value. So, given this function here, all right, looking at this function, you know here you're going to have a maximum value since the A term is less than 0, it's negative. So now to find the maximum or minimum value, in this case the maximum value, we're going to find the vertex. So negative b over 2a is going to equal negative 6 over 2 times negative 3. So it's -6 over -6, which is 1. But remember, the maximum or minimum value is the y. So we got to find f of 1. Which means it's going to be -3 plus 6 minus 13, which means it's going to be 3 minus 13, which is -10. So the maximum value of -10 occurs at x equals 1. And then the domain and range, without even graphing it, you know the domain is all real numbers. You can put any number into the function. The range, well, if that's the maximum value of -10, that means everything is less than it. So that means it's less than or equal to -10. All right, so for a word problem here, it says an archer's arrow follows a parabolic path. The height of the arrow in feet can be modeled by this equation. So basically, you know this is a path here, and the archer goes up, and then the arrow goes down. And so you want to know what is the maximum height of the arrow. So basically, you want to find the vertex. So it's -2 over 2 times -0.005. So when you do that, you get x equals 200. So then when you put 200 back in, when you put it in, you get, and do the math, you get 205. So that means the maximum height of the arrow is 205 feet, and it occurs 200 feet from the release, because that's what x stands for. Now, the horizontal distance the arrow travels before it hits the ground, that is the x-intercept. That means when the height is 0. So you set that equal to 0, and you would solve it. So you would put this in the quadratic formula, and I wrote it out already for you there. So when you simplify, you get this here, and then you add. So this would be 4.101, and then you can go ahead and put that in your calculator. When you put it in your calculator, you get two answers. You get -2.48 and 402.5. Remember, since we're talking about distance, it has to be positive. So it's going to have to be 402.5 feet is where it hits the ground. So the arrow hits the ground 402.5 feet after its release. All right, and then if you graph it, understand that the y-intercept is 5, and then it looks something like this, and it'll hit the, that's what it looks like. I'll show you how to graph that on your calculator in class. Minimizing a product. Decide what must be maximized or minimized. For example, here, you have a product, right? X times y. But you know the difference, x minus y, is equal to 8. So if I solve this for y, in terms of x because I want to make it one variable. So I get negative y equals negative x plus 8. So y is equal to x minus 8. So when I express the quantity as one variable, the product is going to be x times x minus 8. So when I multiply that out, I get the product is equal to x squared minus 8x. Now, I want to find the vertex. So the vertex here is negative 8, because remember it's negative b over 2a. So it's the opposite of negative 8 over 2 times 1. So it's basically 8 over 2, which is 4. So that's the minimum value of the product is when x is 4. And then it says, what is the minimum product? So that means x is 4 and y is 4. So the minimum product, 4 times 4 is 16. So basically, when it says answer the question posed, it says find a pair whose product is as small as possible. So the pair of numbers are 4 and 4, and the minimum product is 16. All right, last one here, it says maximizing an area. So if you want to find the maximum value of an area, so we have a rectangle here. And you have 120 feet, so the perimeter is 120. And you have x and y, right? So you know 2x plus 2y is equal to 120. So then you know that 2y is equal to 120 minus 2x. So then when you divide by 2, you get y is equal to 60 minus x. So if I write a function for the area, because remember, the area is equal to x times y, so it's going to equal x times 60 minus x, which means that it's equal to negative x squared plus 60x. So if I find the vertex, so it's negative 60 over 2 times negative 1, which gives me negative 60 over negative 2, which is 30. So that means the maximum width here, if I let x equal the width, is 30 feet. That means the maximum length is 60 minus 30, which is also 30 feet. So the maximum dimensions are 30 by 30, and that means the maximum area that you could have is 900 feet. 30 times 30. Actually 900 square feet. All right, that concludes our video for this evening, and if you have any questions, please feel free to ask in class. Have a good evening.